Good morning, guys. Happy to have you back here. Let us start with the unit 10 today, which is list, stacks, queues, and priority queues. Look, you have already gone through these data structures. Yes, data structures. You have already covered few data structures in the semester 3. So again, let us start with the introduction part. What is data structure? A data structure is a collection of data. To be specific, a data organized in some fashion. And it is not only the collection, but it also has methods or the procedure to operate these data. So if we talk about object-oriented thinking, then a data structure is also known as container or a container object. This container will store the data, as well as it has all those methods which we can call to have operations on these data. Now, if we are thinking in object-oriented manner, then we can also say that we can create classes for these data structures. So class for a data structure should use data fields to store a data, and it also defines few methods such as operations like search, insert, delete, and so on. So to create a data structure here in the object-oriented fashion, we need to create a class and then create an instance from that class, so that you can apply methods on instance to manipulate the data structure. Now, choosing the best data structure and algorithm for a particular task is a key to developing high performance softwares. So Java has a collection framework which supports or which defines many of these data structures. And it says a container or a container object. So it has mainly two types of containers. One is the normal one, which will simply store a collection of elements, and it is also called simply the collection. Second one will store the key value pair, which is called a map. In this current unit, we are going to look at collections. Maps you will be seeing in the next unit. Okay. Now, common features for all these collections are defined in the interfaces here in the collection framework, whereas implementation of all those common features are provided in the concrete class. So these are the common collections which are there in the collection framework of Java, which has a set which will store a group of non-duplicate elements. Then it has a list, which is just the ordered collection of elements. Then there is a stack, queue, and priority queue. You already know stack is the last in first out data structure. Queue is the first in first out data structure. Priority queue is a queue where each and every element has their own priorities. So this is the hierarchical structure which collection framework has in the Java. If you look at here, it has a number of interfaces, then it has a number of abstract classes, and it has concrete classes also. So the parent of all is this collection interface, which defines all the common methods, properties. As it is interface, which means it will have either constants or the abstract methods, or it can have static methods. There are few interfaces which actually implements the collection interface, which are to be more specific related to the data structure, like set, list, or a queue here. There are few abstract classes which implements these interfaces either directly or non-directly to the collection. These abstract classes defines the abstract methods, or it also defines few other methods and properties. And then there are concrete classes which has the final implementation of all those abstract methods defined in the abstract class or in the interface. So if you look at here, ArrayList is the concrete class. Look, in earlier unit you have seen the ArrayList class and you have also seen few methods of ArrayList. But this is the concrete class which actually extends abstract list class. Abstract list is the abstract class which has few methods and properties. This abstract class extends abstract collection abstract class, as well as it implements the list interface. So this abstract class and this interface has few more abstract methods and so. And then this abstract collection class as well as this list interface both implements the collection interface, which defines all common methods. So either directly or indirectly, this ArrayList class has all those methods and properties defined in the collection interface. So whatever is defined in declared in the collection interface, all these other interface, abstract class or concrete class are going to have it, right? So that's the hierarchical structure for ArrayList. If you look at here, then there is a stack concrete class which extends a vector concrete class. Vector class is going to extend abstract list abstract class, and rest the structure is common like abstract array list. You can also create linked list, right, like this one. Linked list extends abstract sequential list, and it also implements dequeue to generate a queue indirectly, and all these are going to have the collection at the end, right? So this is the hierarchical structure. You can have a look at other abstract classes or concrete classes. We are going to look at ArrayList, linked list, then the stack, then queue, and the priority queue in this unit, which is actually the part of your syllabus. So let us start with the parent one, collection. Okay, collection is nothing but the interface which defines all the common features of all these collections. As it is interface, it is just going to have the properties and the declaration of all the methods to manipulate these elements. So methods are just the operations that you want to perform on the collection. Okay, so these are the common methods defined in the collection interface, and these common methods are going to have, you are going to have these methods in all those collections, whether it is linked list, array list, stack, queue, priority queue, anything. So there are two different methods to add an element in the collection: add or add all, which is going to add a given element or a collection of elements. It will add all these elements in the collection. Then there is a clear method, which will simply remove all the elements which are there in the current collection. Then it has few methods to just check whether given object is present in the collection or not, so which is the contains or you can check multiple elements are present or not by just giving as a collection as a parameter here, and the method is contains all. These two will simply return boolean true or false. Then just to check whether two collections are equal or not, you can pass second object and the method is equals. Again it will return either true or false boolean data. Then there is a method to just have the hash code of the current status of collection. Is empty method will simply check whether the collection is empty or not. Then two methods to remove a single object or remove all multiple objects from the collection C. Just return a boolean true or false. Then this is just the negation of remove all, so retain all. It is going to retain all the elements which are given here in this collection C. All other elements will be removed. Then the size method, which will simply give you the size of your collection, and to array method, which is going to convert your collection to the array object, and then you can iterate your array. Okay, let's have a look at few of these methods. The collection is the interface, so we cannot instantiate an interface directly. Definitely we need to go for a concrete class, and ArrayList is the best example because you have already gone through ArrayList earlier. So we will create an ArrayList object and we will use some of these methods to just have an idea how it is working. So I'm moving to the Eclipse editor where I do have the code already. I'm just going to explain it in front of you. So we'll create an ArrayList. ArrayList is a generic class, so we need to define what data type we are going to store here. So I'm defining a string, create a variable, and instantiate an object. Now this is the constructor of ArrayList, no argument constructor, so it is going to create empty ArrayList right now. Now on that ArrayList we can call add method. Now this add method is coming from the collection interface. So we add a particular object. I'm going to define a string because I have ArrayList of string objects. So I'm going to add multiple city names here. So we add multiple cities, and if I just want to have print or I just want to display that entire array list, then we can go through the system out println array list, which is by default going to call toString method, and it will print the entire array list on the screen. So let me run this code and have a look at the output. So an array list of cities, and here we have the output which has all those city names: Ahmedabad, Bhuj, Gandhinagar, Rajkot, and Surat. ToString method actually converts your array list into this format. Okay, so we have looked at the add method. Then there are few other methods which you can use. So let me uncomment this code. You can check whether a given object is present in the collection or not using contains method. So I simply check ArrayList.contains Rajkot. If it is going to return true, and if my condition is true, I'm just going to have this message on the output. Then we can check whether list is empty or not. Is empty is the method. If it is empty, list is empty is the message. Otherwise, list contains element is the message. Then you can remove particular element from the entire collection. So remove is the method, and you pass in the element that you want to remove. So I want to remove Ahmedabad, and then if I print my array list again, it is not going to have Ahmedabad at the output. We can check the size, as well as we can convert our entire array list to array. and once I have the array, I can convert it to string to just print on the screen. So let me save this code and have a look at the output of these methods. So if I run the code now, then I'm going to check whether it contains Rajkot. It says yes, Rajkot is part of list. Then I simply check whether array list is empty or not. So it says list contains elements because it has multiple elements here. Then I remove Ahmedabad and I print array list again. So after removal, it prints the entire array list, which does not contain Ahmedabad. After removing Ahmedabad, we only have 4 cities here, so size is 4. And when I convert my array list to array, then array cannot be directly converted to string. So either we can iterate it using for loop or for each loop to print all those elements. Right now it prints the object. So the toArray method, it is going to convert our array list to the object array. So here you have the object array, okay, at this position. So these are the few methods of the array list. Now actually we are operating these methods on the array list, but these methods are coming from the collection interface actually. So that's the collection interface. Now if you want to iterate your interface entirely, collection entirely, then you can have iterator object. Now iterator is a classic design to iterate or walk through all the elements which are there in the current collection. So collection interface actually extends iterable interface. Iterable interface has a method iterator, and that method is going to return iterator object. Now iterator object is actually of the iterator interface, which defines few methods which will be helpful to iterate a collection. Now, just to understand this entire thing, let's have a look at the graphical structure here. So our collection interface extends the iterable interface. Now iterable interface has one method iterator. Collection interface extends iterable interface. Iterable interface has one iterator method. Now this iterator method is going to return iterator object. Now, this iterator object is actually of the iterator interface, and this iterator interface has few methods which will help us to iterate our entire collection. So those methods are simply just, if you want to check whether your collection has next element or not, you can have has next method. If it has, you can go for next method, which will return the next element. Look, next method will simply return the next element, it will not remove it. If you want to remove also, then you can have the remove method, which will return the element and it will also remove that element from the collection. So let's have a look at the iterator implementation here on the array list. Moving back to Eclipse, we already have one array list. Okay, let me comment all these methods so our output is cleaner. We have one array list and it has these 5 elements in it. Okay, now we want to have a look at the iterator. So your array list has a iterator method because our collection interface extends iterable interface. So we have this method, iterator. Iterator method is going to return iterator object. So we need to have iterator object. Iterator is again a generic type, so we need to define what kind of objects we are going to iterate here. So we define it as a string and we declare a variable. So iterator method will return iterator object. Once we have iterator object, we can call those methods. So on that iterator we can check whether it has next element or not. Till it has a next element, we are going to have a while loop, and within that loop we are going to access the next element. We access the next element and we simply print it. That's it. So till your iterator has a next element, it is going to access that next element and it will print on the console screen. So I say iterator, on the same line I print all those elements with a space. Okay, so let me save and let me run this code to just have a look at the iterator. So I have iterator which will print all those cities in a single line with space in between. So we have Ahmedabad, Bhuj, Gandhinagar, Rajkot and Surat. These are the cities that we have added earlier. Okay, so if you just print your array list also here, so I have array list, I add all those cities, I print my array list directly, and then I print my array list using iterator. Then both these will have the common output. So here is the list I print directly, and here is the list I print using iterator. Okay, so that's the example of iterator. Let's revise again. Collection interface extends iterable interface which has iterator method, so we can call iterator method. Iterator method is going to return iterator object, so we have iterator object here. An iterator object has few methods which we can use, has next and the next method. This is how we call iterator. Moving back to presentation. Next, and now we will actually start considering the lists. Up till now everything was the basic. So let's start with the list. List is again an interface which extends the collection interface. So all those common methods declared in the collection are there in the list by default. Now, Java list has two concrete classes, ArrayList and a linked list. List interface adds a position oriented operations. Actually, the collection interface has all the methods which will work with the element, but it does not have any method which works with the index value, position. So we have a list interface which adds those methods which work with the position orientation, so index kind of thing. So this is the list interface which has add method and add all method. Actually, collection interface was having add and add all methods already, but this list interface is going to override it. These two methods, add and add all, has those elements or collections by default, but in addition to this one, it has an index parameter also, which defines on which index you want to add this element or on which index you want to add this entire collection. Then as you have the index, you can access particular element at the given index, so get method. You can also check the index of given object or the element, So what is the index of given element, what is the last index of given element, and so on. Now it also defines new kind of iterators here. Using list iterator, okay, you can iterate your list either forward or in a reverse manner. Even using list iterator, you can start iterating your list from the given starting position also. So it has a start index parameter. It has a remove method if you just want to remove an element at the given index. It also defines a set from index and the element. Oh, sorry, it is going to set a particular element at given index with the new element given here. It is just going to override older element with this element at a given index. And then it has a sublist method, which is just going to return sub part of the list starting from this index up to this index. Now this to index is excluded, okay, so actually elements will be covered up to 2 index minus 1. So these are the few list methods. Let's have a look at list iterator also, and then we will look at the examples. So list iterator is again an interface which defines few extra iteration methods. It extends the iterator interface already, so it has all those default methods like has next method, next method, remove method. In addition to those methods, it has few more, which is add a particular element, set a particular element. Now this add and set is not going to have any index value here because every iterator has their own current position. So add method will work on the current position, set method will work on the current position only. It has few extra methods here. As I said, using list iterator, you can traverse your list in a backward manner also. So to have that, it has few methods like has previous, will just check whether the previous object is present or not. Previous index, what is the index of previous element? Previous, which will return the previous element. And like previous index, it also has the next index. What is the index of next element? So these are few list iterator methods. Now let's have a look at the list methods and list iterator methods in practical. So moving back to Eclipse editor, I'm going to comment this iterator here, and I will uncomment few methods that we want to see here on the array list. So we already have 5 cities added in the array list. Before running this, let me comment and let me run this code once to have a look at what is the current array list we have. So we have Ahmedabad, Bhuj, Gandhinagar, Rajkot and Surat, which will have the index values like 0 to Ahmedabad, 1 to Bhuj, 2 to Gandhinagar, 3 to Rajkot, 4 to Surat. So 0 to 4 index values. Okay, now let me uncomment this code. What we are going to do now is, earlier we have added all the elements using add method, and those methods does not have any index parameter, but now we will call add method which will have index parameter also. So we are going to add Vadodara in that array list, but I'm going to add the city at a given index 4, and then I print my array list again. So this is going to take place of Surat actually, and Surat will be pushed back to the index value 5. Then we can check index of method. So what is the index of Raj code? You can also have the sublist 2 to 4 sublist, so it will return index value 2 as well as index value 3. So 2 elements are going to have on the output screen. So let me save and run this code. So when we add Vadodara at index 4, it is going to push Surat at index 5, and before Surat, Vadodara will be added here. Okay, so that's the add method. Then what is the index of Raj code? So 0, 1, 2 and 3 is the index value of Raj code, and 2 to 4 sub, so 0, 1, 2. So starting from this 2, 3 up to 3, so Gandhinagar and Rajkot will be the sub list of the array list. So these are few methods from the list interface. Okay, and then we want to see the list iterator actually. So we will call the list iterator method. It is going to return list iterator object. So we have list iterator 1. Now using that object, we can traverse our list in a forward manner by just having has next and next method. So this is going to traverse entire linked list in the forward manner. Now, if you just want to traverse your linked list in the backward manner, starting from the end up to the first one, then when you call the list iterator method, you want to start with the last position, which is actually the size. So we want to start with this position, and once I have the list iterator object, I'm just going to call has previous method to check whether there is any previous element or not. And if I do have the previous element, I will access it using previous method. So I'm going to have the forward iterator and the backward iterator also. Let me save and run this code. So here in this output, we have iteration in the forward manner. So Ahmedabad, Bhuj, Gandhinagar, Rajkot, Vadodara, Surat. And then we have the iteration in the reverse manner, backward manner, starts from the Surat, Vadodara, Rajkot, Gandhinagar, Bhuj, and ends at the first one, which is Ahmedabad. So that's how we can iterate any list in forward or the backward manner. Okay, so I'll comment this code right now because we will going to see few other methods later on. Back to the presentation. Next, actually we want to see is the concrete classes. We have already seen ArrayList. We will discuss ArrayList a few points. So ArrayList class and the LinkedList class, these are the two concrete classes implementation of the list interface. Actually we can say ArrayList stores the elements in array, whereas LinkedList stores the element in the linked list manner. What is the difference? Just that you have already learned the difference between array and linked list. That's the same thing here. When you are creating an array list are stored in the array, and array has a predefined capacity or the size. But here ArrayList is can grow or shrink dynamically. So here it is going to use the dynamically created array. Now that array, whatever is being used to store the elements of ArrayList, will have enough size initially to store all the elements, and when you add a new element, if there is no empty space for the new element, then your array will be dynamically grown. Now actually your array is not going to be grown directly. If there is no space for new element, Then new array with enough size will be declared. All the elements in the older array will be transferred to the new array, and you will have that new array as the array list. That's what is going to happen in the backend process. So which one do you use? It purely depends on the specific needs. So if your application needs to have a support for random access through index, then you go for ArrayList. If your application does not need to have a support on random access, it is just going to have the sequential access, or it just wants to have insertion or deletion operation at either end, first or last, then you may go for the linked list. So what is ArrayList? As I said, ArrayList is the resizable array implementation. If there is no enough space in the current array, then new array will be declared, existing elements will be transferred to the new array, and then new array will be assigned to the array list. So it is growing the capacity dynamically. But ArrayList cannot shrink automatically. If you want to shrink your ArrayList, then you need to call trim to size method. This is the ArrayList. It only has the constructors and trim to size method. Rest all the methods are coming from collection interface or abstract class or list interface. Okay, so there is a constructor, no argument constructor, which will create empty list. Then there is a constructor which takes one collection object, so all the elements which are there in the collection will be added to the array list. There is a constructor by which you can define initial capacity also, and then there is a trim to size method. So this is the ArrayList class. So let's have a look at ArrayList class. Oh, we have already gone through all the methods on the ArrayList. So we will directly move on to the LinkedList class now. LinkedList is the linked implementation, LinkedList implementation, okay, of the list interface. It has few methods to insert or remove element from the both ends, first and last, and it has few constructors, no argument or the constructor with one parameter. So let's have a look at it. It has a constructor without any parameter, which will create empty linked list. It has a constructor with one parameter collection object, so it is going to have all the elements which are there in this collection. Then it has few methods to either add first or add last, remove first or remove last. So it is going to have insert and delete operation on the both ends, first and last end. And it can also give you the current element from the first or the last position. So get first or get last is the method which is going to return the first or the last element. So this is the LinkedList class. Let's have a look at the LinkedList class. So I will uncomment the code here, where we are going to have a look at the few methods of LinkedList. I'm going to use a LinkedList constructor with one parameter, and I'm going to pass a collection here. ArrayList is indirectly a collection, so we pass ArrayList here. So if you remember, we already have ArrayList with these 5 cities in it. Okay, so I'm going to add these 5 cities in my linked list directly using this constructor. So I have a linked list now. Now from that linked list, I'm going to remove my first element, which is Ahmedabad. I'm going to add first element also to be Vadodara. So Ahmedabad will be removed, Vadodara will be added here, and then I will print my linked list. So let us save this code and run it once. This was the array list. Now from this array list we have removed Ahmedabad, and instead of that we have added Vadodara here. So we have the linked list of Vadodara and then Bhuj, Gandhinagar, Rajkot, Surat as it is. So this is a linked list. Now you can add any element here, either at first or the last end. You can remove any element from the first or the last position, but as it is linked list, it is just going to have those methods. Now, but it is kind of a list, so you can have the iterator here. You can use list iterator to traverse the linked list in a forward manner or the reverse manner, just like the array list we have traversed. So let me uncomment this code and run this code to just have a look at the forward manner, Vadodara, Bhuj, Gandhinagar, Rajkot, Surat, or the reverse manner starting from Surat going all the way up to Vadodara. So this is the reverse manner traversing linked list. Okay, so that's the example of linked list. I'll comment this part of traversal only, so to have this linked list as it is, and let us save this code. Going back to the presentation, next part we want to see is the comparator interface. Now this will be the last topic for today also. Okay, now you have learned the comparable interface, okay, where you have the compare method which is going to compare the two objects of the same data type. But there are multiple places where we need to compare two elements of different data type, let's say. So comparable interface will not be used directly. A comparable interface is by default implemented by many of the inbuilt classes like string, date, big integer, big decimal, all the numerical wrapper classes, and so all those has a comparable interface. So that's why you were able to compare those two values directly. But what if we want to compare let's say a circle with pentagon? What if you want to compare, let's say, a person, human, with animal? Likewise here, let's say if you want to compare, what if you want to compare array list and a linked list? So all these are the examples where you want to compare two objects, but those two objects has a different data type. In those cases, you can do that using comparator interface. So comparator interface we can define, or we can use to compare two elements of different classes. So for that, what we need to do is we implement the comparator interface, and we define the abstract method of comparator interface, which is the compare method, having this definition: public integer, it is going to return integer value. If given two objects are equal, it will return 0. If first object is greater, then it will return +1, and if first object is lesser than the second one, then it is going to return -1. Then compare is the method name, and it is going to have two parameters, two elements. T defines the generic type. So we need to define what kind of objects we are going to define, we are going to compare here. Okay, so that's all about comparator interface. This is only the theory, but let's have a look at the practical part here. And we are going to compare, let's say, two objects. Let's say I want to compare ArrayList with LinkedList. Now this is not possible directly because ArrayList and LinkedList does not have a common data type. Even these two are not the a primitive data type, and these two classes does not implement comparable interface also, so it gives us error. Now, this is not possible. So direct comparison is not possible, so we need to go for the comparator interface. So what we need to do is we need to define a class which implements comparator interface, and we need to implement the compare method there. So let's have it. Let us define a class list comparator. Now this is a new class, user defined class. So let's go to that class first. Let us understand what is there, and we'll come back here. So I'm scrolling down where I already have this class. So I have a list comparator class which implements comparator interface. So I need to define what kind of data types I'm going to compare here. So ArrayList and LinkedList both are of a type list. So I'm going to compare list here. And then in this class, I will implement that abstract method, which is compare method. And here I'm going to have all those or those two objects here, 1 and 2, C1 and C2. Now C1 will be ArrayList, C2 will be LinkedList, but I can store those nodes or the objects in the parent data type, which is list here. Yeah. Now once I have C1 and C2, I can compare these two elements based on a common parameter. So both will have sizes. So C1 size and C2 size. If C1 size is lesser, which means the first object is lesser, we will return -1. If these two lists are having same size, then we will return 1. Then the last case will return, sorry, if both these have equal size, we return 0, and then the last case we will return 1 from this method. Okay, so we have compare method, which is going to compare these two lists based on the size. That's it. We define list comparator class like this one. Now let us use this class. So going back to the list comparator object creation, we create a list comparator object, and then we call a compare method of that list comparator, and here we pass ArrayList and LinkedList. That's it. We pass two objects. Now this compare method will compare these two, and based on the size of these two, it is going to return me 1, 0 or -1. So I'll simply check. If it is 1, then I will print the array list. So I'm just going to have the largest list on the screen. So if it is 1, print the array list. If it is -1, you print the linked list. And if it is 0, then you simply say that both are equal in size. That's it. So that's how we compare two different data type objects. Okay, let me run this code and have a look at which is printed on the screen. So largest list, but it says both are equal in size. Equal in size, remember, because even array list and linked list are going to have total 5 elements. those element values are different but size is equal. Both has 5 elements. So that's the comparator interface example. Back to the presentation slide. We will stop here. We'll go and look static methods for list in next session. Thank you for joining today.